All right, so let's take another look at coupled equilibria. Again, this is just a review of previous information, and it's important to consider coupled equilibria because things aren't generally pure, right? So things generally aren't pure. It's not like you have a reaction mixture with just two things. Chances are there's other stuff in there, right? So there's a mixture of things. And so then you're going to have a mixture of equilibria. Right, so it's similar like an ecosystem where some of all of these things are interacting to form your final product. So for example, if we have silver chloride plus some ammonias, this can form a coordination complex as we've previously seen. Right, and so we generally consider silver chloride as insoluble. And then we generally consider this silver ammonia complex as soluble. And so the question is, if you add ammonia to a solution with solid silver chloride, will it dissolve? Right? Will it dissolve? Will the products be favored or will the reactants be favored? And so what we're talking about here is this K, but currently we don't know what this K is. If you try to look up this K, you might not be able to find it, right? So whether it's going to be soluble depends on K. And if we have a large K, then it'll be in the forward direction, so it'll be soluble. If we have a small K, it'll be in the reverse direction. And so you can't, maybe you can solve this if you know some things. Right, so if you know some data, right, so here we have silver chloride dissolving into silver plus and chloride minus, and we know this KSP value is 1.77 times 10 to the negative 10. And then we also know the Kf for the formation of this silver ammonia complex. Right, so this Kf was equal to 1.7 times 10 to the 7. And so let's take a look at what we kind of want to solve for up here, this K, and compare it to the Ks that we already have. So think back to the coupled equilibria section, right? So we're going to find silver chloride, find out where we see it. Well, I see it right here. And so the coefficient's the same. Everything is good. I shouldn't have to do anything to this equation. Next up, we have these two ammonias. I see two ammonias right here. It's a reactant in both sides. The coefficient is the same on both sides, so I shouldn't have to do anything to this equation. So what I can then try to do is sum these two equations, and when I do that, the silver pluses on each side will cancel out. And then I have AgCl plus 2NH3 going to our complex plus our chloride, right? And if we think about this equation originally that we want to solve for and compare it to what we have so far, we have silver coming up first, two ammonias, and then in the product side, we have this silver ammonia complex, and then finally we have this chloride. So it looks like exactly what we want. And so remember back to coupled equilibria, when we add our equations, we multiply our coefficients, or multiply our k's. And so the final value is 3.0 times 10 to the negative 3. And so while this value isn't huge, it is way, way bigger than the solubility of silver chloride, right? So it's times 10 to the 7 bigger. And so the final conclusion you can make here is that the more soluble, or that this complex is more soluble than AgCl. And so that's what this picture right here shows. In this top solution, you have your silver chloride and it's precipitated out. And then what you're going to add to it is some ammonia, and you can see that your stuff dissolves. So we'll see a lot of this in our qualitative analysis labs.